guys, so we're on January 2020, question 8, part B. So this question has to do with completion of the square. So the function f is defined as follows. F of x is equal to 4x squared minus 8x minus 2. So we have to express f of x in the form a open brackets x plus h all squared plus k, where a, h, and k are constants. So this method is the method that I teach my students. So it involves firstly factorizing the coefficient of x squared, which is 4, from the first two terms only. So we have 4 times x squared minus 2x. The next step, we're going to take half the coefficient of x, and the coefficient of x here is -2, so half of -2 will give -1. Then we're going to square that -1 to give +1. So inside of my brackets, I am going to add that 1. And then at the end, we're going to subtract 4 times the 1. And of course, the reason for doing this is that the part in brackets is going to be a perfect square. And then the reason for subtracting the 4 times the 1 at the end is to keep the balance of the expression the same. Alright, so part in brackets is a perfect square, which is of the form a squared minus 2ab plus b squared, which would factorize to give x minus 1 squared. And then at the end, we have -2 minus 4 will give -6. Okay, so we have completed the square, and this was worth 3 marks. So let's look at part 2. So part 2 says state the minimum value of f of x, and this is worth 1 mark. So the minimum value of f of x is actually the value of k when we've completed a square, and in this case, it is -6. So the minimum value of f of x is -6. And part 3, determine the equation of the axis of symmetry, and this is worth 1 mark. So the axis of symmetry will be when the part in brackets is equal to 0. So when x minus 1 equals 0, then we get x is equal to 1. Okay, so that's our equation of the axis of symmetry. So let's go on to part C. Now part C is on a completely different topic from quadratics. So this has to do with distance time and speed time graphs. So we have a speed time graph which shows the 3-stage journey of a car over a period of 40 seconds. So for this question, we have to determine the acceleration of the car for each of the following stages of the journey, stage 2 and stage 3, and this is worth 3 marks. So for stage 2 of the journey, you realize that this part of the graph is a horizontal line, meaning that the velocity or speed is constant during this stage between 16 and 32 seconds. So when the speed is constant, it means that there's no change in speed. Now, acceleration is defined as the change in acceleration with respect to time. So if there's no change in the speed, it means the acceleration is equal to 0. All right? So therefore, for stage 2, the acceleration is 0 since the speed is constant. Okay, let's look at stage 3. So stage 3, and this part of the journey, we see that the speed is decreasing. So the car is actually what we call decelerating. Right? So the acceleration, change in acceleration, let's write down the coordinates of this point. That will be our first point, and this point, our second point, when it comes back to rest. So the first point is at 3212, and the next point is 40, 0. Now, acceleration for a speed time graph is actually the gradient of the graph between 2 points. So you can actually use the formula for gradient to find out the acceleration for stage 3. So we're going to use this as x1, y1, and this is x2, y2. So I'll do the working right here since we have the coordinates. So the acceleration will be 0 minus 12 over 40 minus 32. 0 minus 12 is negative 12. 40 take away 32 is 8. And if we reduce this by dividing by 4, we get negative 3 over 2. So negative 1.5, which is our acceleration.